Okay. So, all right. So the difference about what we're going to do today is it's going to be very similar. It's going to be very similar to what we have been doing, but we will be rotating around lines that are not the X or Y axis today. They will still be horizontal or vertical, but they will not be the X or Y axis.
About the y equals 1.
Yes. All right, so it's just going to change our radius, our radii a little bit. So we are supposed to find the volume of the solid generated by revolving the region bounded by f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1.
So what exactly would the fulcrum be?
So the line y equals 1, is that vertical or horizontal? It is horizontal. So in this particular case and on the notes for 810, we are rotating around that green line right there. So that line y equals 1. So the bottom boundary is what we're rotating around.
So it's going to do with that kind of thing.
Arrow is so clean. Yeah. Wait, did you draw that? I looked away for a second.
Okay. Yeah. Okay.
Wait, so it's doing this, right?
All right.
It's like 3D.
Okay. All right. So, what we have to think about here is we need. I'm going to write this like we have an outside radius and an inside radius. I'm going to treat them all like they're washer method problems, like from here on out, since we learned washer yesterday. Although our outside radius is going to be a little bit difficult to find. Not difficult, but we'll have to think about it a little bit. Inside radius, what's the inside radius? It's going to be 0 because our figure that we're rotating touches that line for the entire section that we're looking at. So I'm going to treat these all like they're washer method problems, just because then whenever we have ones that actually do need the washer method, we've been doing the same thing the whole time, and we don't have to think about two separate rules. But we do need the radius here, which is going to be from that purple line to the line that we're rotating around. So, now if I use the equation for the purple line, that will give me my y value all the way down to that x-axis. That would give me this length. So for just to have that red line, then I need my radius to be 2 minus x squared, which is the purple section here, and I have to subtract 1 because it's up 1. Okay. Yeah, 2 minus x squared gives me the distance from the x-axis, but I don't really want the distance from the x-axis here, because I'm rotating around that line y equals 1 instead. So I have to subtract out this distance here, which is 1. And that'll give me the red line there.
So the distance will change based on where it is in the y.
Yes.
So how does subtracting 1 do that? Oh, it's up. Oh,
Yeah.
okay. Yeah. I see that. The units.
Yeah, because if we didn't have the 1 there, then it'd be like we were rotating around the x-axis, which would give us all of this extra space here in the middle. So by subtracting that out, that gets rid of it. It depends on where your function is in relation to the line, like which one's on top, but you have to kind of think about it with every problem, because sometimes you might have to add.
So is that like if they're on two opposite sides of the x-axis, you should add it?
Yes. Yeah.
So
You can kind of think of it that way because, like, what's really happening here is, like, whenever you simplify this, it's going to give you 1 minus x squared, right? No, because you're just, you do not distribute that negative because you don't have a parentheses around that. You would just have to combine that 2 and that negative 1 right there to get this 1. So it is kind of like you've just taken 1 away from your y-intercept there and moved it down so that it's next to the x-axis instead of the line y equals 1. So you can kind of think of it that way as well. So to integrate this, we're going to do pi times, quiet, Daniel and Jack. Daniel, I'm going to start taking, you and Selena both going to have to give me a bathroom pass. If y'all keep saying inappropriate things. And then I'm going to have to start taking from everybody else. For inappropriate things. Should I bring the jar back out?
Absolutely.
I just let it slip because I got.
Let's do it.
I had a reason.
All right, so how about not saying don't tell anybody shut up anymore, okay?
Every time you guys.
So that I don't have to take those away. If it's bad enough, I'll just send you straight to Mr. Wolf. Okay. All right. All right. All right. So we've got pi times the outside radius squared. I could do minus pi times the inside radius squared here. But it is just 0, so that's going to go away, right? And then what are our limits that we need to integrate with respect to? -1 to 1. X-axis, so from here to here. Yeah, dx, yes. So, dx. And of course, this, you do not have to write this. I'm just writing this part right here to prepare us for when we do need the washer method there. Okay? All right. So we're going to just integrate this with the calculator like we've been doing because we... Thomas, you want to give a bathroom pass?
Rowan, I'm sorry, you're doing much better in your class than I'm doing in here. And that reflects my grade.
You got a few points back. All right. Everybody else is going to have to get bathroom passes.
I didn't say a word. It was Margaret. I believe in Tommy's word.
Yeah, it was all Margaret. Yeah, Margaret.
All right, so we'll get 16 pi over 15. 16 pi. 16 pi over 15, if I typed it in right. That is your inside radius. So in this case, it is just 0. So like, whenever we're doing washer method, we have to do the outside radius times the inside radius for the hole. This one does not have a hole, so it just, that part just goes away. Yeah, yeah. This is optional. I'm just throwing this in here because in a minute we're going to do some problems where we do have an inside radius. So we're just like constantly looking at that. Chandler. Maybe later. Bromley. No, not for that.
Question's been invalid.
get it tomorrow. It's okay. I'll just get it tomorrow. There's not a submit button. You said those to take online submissions, Daniel. All right, yes.
Yeah, give her all some math notes. Give her some volume with this.
I don't have an extra one, but she's welcome to take notes on her own if she wants.
Just stay with us for the day.
Yeah, stay with us. Come on. Good. Take notes on this.
You can stay if you. I mean, do you have a class? Oh, you can stay if you want. You're welcome. Okay. All right, number two. All right, here's our area that we're looking at.
Wait, so for the radius thing, it's always going to be pi parentheses whatever number that's square, right? And then minus all that.
Oh, wait.
Just power square.
There we go. The green area here. And so this will kind of answer the question that Laura asked about sometimes having to add something instead of subtract. Because we are, actually it may not. No, it won't. It would if we were rotating around that red line. I was thinking of the other one. Yes. All right. Okay, so we've got this area, and we're going to rotate around the line x equals 1. Which line is that? Vertical, and it's this one right here that we're rotating around. Okay? All right, so if I'm rotating around a vertical line, Daniel, is that going to be in terms of x or in terms of y? It's going to be y's. So my equation is not in terms of y. So I need to solve it for y. So I've got y equals x minus 3 cubed. I will cube root both sides and add the 3. So I'll get the cube root of 3, or cube root of y plus 3.
3 is outside.
Yes, outside. You may want to even write it like this, 3 plus the cube root of y, just
to clarify.
just so you don't accidentally put the 3 underneath the cube root.
No, I'm pretty precise with my
So that is our equation of the purple line there. It is purple, but when I highlighted it, kind of turned black. All right, so, oh, am I recording? I think I did, yeah. Test corrections are tomorrow, FRQ tomorrow. They're not like for half credit back. They're a separate grade. All right. All right, go away, back to work. All right. All right. Okay. All right. So, if we're thinking about what we have here, we need to know this length. That would be our outside radius. All right, so it's always a little confusing to me for when we're dealing with y's here, but we have this graph. So when I look at the equation of a function and it's in terms of x, like I have here, that equation right there gives me the distance from the y-axis over to the equation. So to get that red distance right there, I have to take my equation, which I'm using the one in terms of y, so 3 plus the cube root of y, and I have to subtract out this little piece right here, which is 1. Where this is our big R. You're right. Oh, I didn't need a Y. Let's make this a Y. Okay? So, what is the little r for this one? What's the inside radius? It's 0 because we're rotating around that. We're rotating around the line like this. For these notes right here, they are, but when we get to 12, which we'll do here in just a second, it will not be, because those will be ones that have like the holes. Okay. All right. Yes. That should be Y's there. Sorry. So we are going to integrate. What limit should I use for my integral? Eight. Y equals 1, y equals -1 to 8. Yeah. This one right here, that's -1 up to 8 there. And so we would have pi times that outside radius, which is 2 plus the cube root of y squared. And then, this part's unnecessary for this particular problem, but pi times 0 squared here. You can put the pi on the outside if you want, yes. So it would be perfectly fine, of course, if you wrote it like this, -1 to 8. I put the pi on the outside. You had 2 plus the cube root of y squared dy. And you don't necessarily have to write the way I'm writing it here. I'm just doing that for the purposes of tomorrow. Oh, not tomorrow. So we are going to integrate. Yes. It's a cube root, so it's going to make it worse rather than better if you do that. What I usually do is just raise it to the 1/3 power. It's somewhere on here, but I'm not sure where. So I usually just do y to the 1/3.
I think it might be the next step after this. So, would you plug in the inputs into this, the 2 plus?
You would have to integrate it. So, like if you were doing this by hand, you'd have to integrate first, and then you'd plug in the 8 and the -1. But, if you do, they'll be pretty simple equations. Where have I messed up? I think I need to not have that parentheses. There we go. So 189 pi over 5. So that one you could integrate by hand, but it'd take you all day to do it. So we're just going to use the calculator.
All three go wrong.
Mine is wrong because I need an extra set of parentheses around my 2 plus, because see my square's on the inside of those parentheses instead of the outside. 5/4 pi over 5.
Ooh, that math of that little right?
I'm going to bring the jar tomorrow. It is. Tomorrow is going to be Friendly Friday.
Okay.
And y'all are going to be nice to each other, or I'm going to take your bathroom passes.
Every Friday.
Every Friday we get a free pass. Meet Monday, and that's where we just.
Then I will make myself a note that you owe me
I'm
a
gonna
bathroom.
bring fake back.
Counterfeit?
I'm going to make myself a note. Please don't make me have to keep up with them closely. All right. Okay. All right. Okay, we need to find the volume of the solid generated by revolving the region bounded by 4 minus x squared and y equals -5. So I think around the line x equals -5. I don't know if I meant for that to be x equals -5. I'm pretty sure I did not. I think I meant for it to be y equals -5. It has to be.
There's already a Y.
Let's make that a y.
There's 2 Y.
Yeah, they're supposed to be y. Both y. Let's make these both y. Alright, so,
Shouldn't it be to the right?
Oh, you are too, Tommy.
alright,
Anybody better than you at that?
yes. Alright, so your quadratic's going to look like this. Your y equals -5 looks like this. I think your brother needs...
Thank you. Good luck in Spanish. Are you? I mean, are you really intelligent? Are you?
Thomas, as much as those bathroom passes mean to you...
No, we totally don't.
All right.
See, I don't actually mean anything that I say to anybody. I don't expect it to take personally because I don't take anything personally. That's a good way to think. Yeah.
I feel that
Yeah, that's why I stopped talking to Margaret since when was it, English? Yeah, whatever. Me and Miss Wall's been named her for 1 or 2 days.
So you just omitted her?
Yeah, so now I don't talk to her anymore.
All right. Tomorrow, I'm going to bring the jar.
You will see the nicest version of myself.
Friendly Friday.
It's not going to stop tomorrow. Yeah, I'm going to forget. That's what I won't get. I could literally mention it right now.
All right. Okay. All right.
You look like the guy.
So,
The little kid that got knocked.
Oh, yeah,
somebody let Brahma back in. No.
It's really Friday.
All right. Okay. Now this one's a little bit trickier. This will answer the question Laura had asked about earlier. So the outside radius for this one is really the only one we've got to think about. Inside radius, what's it going to be for this one? 0. So, whenever I look at this equation, I need to know all the way from the equation down to this line of -5, right? So, whenever I look at this equation, y equals 4 minus x squared, if I plug numbers into that, that gives me from the equation down to the x-axis. So, I will need to take that equation and add the 5s here. So, here's an example where you would need to add the 5. So, we would have 4 minus x squared plus 5. So, the green part right here that I have, that is the distance from the x-axis to the equation. So, like if I plug a number in here, it's giving me the y value, which is from the x-axis to the equation. So, the equation itself only gives me this piece right here. So, I got to add that 5 right there.
You do that with y?
You can also do this with y's, yes, it'll be left and right. So, right here, we're not squaring anything because we're just combining the 4 and the 5. Because we've not plugged it into the equation yet. That's just our capital R. Our lowercase r is, of course, still just 0 for this one. And so, we will integrate. What limit should I use? This is a dx.
Oh, wait, that's that too?
-3 to +3. Oh.
It's gonna be work. No, you're right.
Alright, so again, it's fine to write it like this, -3 to 3, and just have that 9 minus x squared. The 0 I'm just putting over here for the next problems that we're going to do. And so we will integrate that. We're going to use the calculator for sake of time here. This is one you would see without a calculator, possibly. It's not terrible. Well, I don't know. Plugging that -3 and 3 would take a while. Integrating would be pretty. You would distribute first and then integrate. What would become the most difficult is plugging in -3 and 3. Yeah, it would probably get pretty ugly if we tried to do it by hand. So, 1296 pi over 5.
What the?
Will be our answer. No, we've got more notes.
Do we have homework? Please say no. I'm down.
I might make it do Monday since you have a couple other things to do.
I appreciate it.
All right, but that doesn't necessarily mean we're gonna have like class on work on it tomorrow. But
Are you gonna be in here during third tomorrow?
that should be yes.
Thank God. If she's not, then
She teaches 4 classes.
All right, questions on that? Okay, let's look at what happens when we have a hole in the middle. So same idea here, but we have a hole in the middle this time.
Add the wall. Add the wall.
or you get 3 units. So for this one, little r is not just going to be 0. Don't you just
Right.
distribute the plus 1 if it's kind of
It depends on what it looks like.
yeah, like distribute the difference.
All right, so let's sketch ourselves a graph for this one. We've got x equals 0, square root of x, y equals 1, and we're revolving around y equals 1. Y equals 1 is that horizontal line, so All right. We really just need 1 and 1 here, I think. And so we'll have the square root of x looks like this. And then we've got x equals 0. So x equals 0 is our y-axis. And then y equals 1. Hold on, did I mean to do this? Because this is not a washer problem.
But it's revolved around y equals 1.
Because our area is this right here. But it's not a washer. Yeah, because it's around that red line. If it's around the x equals 1, it would be.
Can we just change it to x then?
Let's change it. Let's change it because I want it to be. Usually I do these on separate days, so I might have wanted to do that one just sort of as a review, or I might have just messed it up. Not sure. Right. All right, so let's revolve around x equals 1. Okay, so if we're taking this yellow area here and we're revolving it around x equals 1. Okay, the outside radius will go from that dotted line all the way to the green line. Right? So what is that outside radius? It is 1. So like when we rotate this, if we just look at the outside, it's just going to look like a cylinder, right? But it's going to have a hole in the middle of it. Sorry about that. Yes, we are doing this. So we do need to, since that's a vertical line, it doesn't even in terms of y, which means I should be using y's right here because I always forget. Still there's yellow region, yes. Okay, so lowercase r is the one that is a little bit more difficult to find here. So let's talk about, well, first let's do y equals square root of x. We're going to solve it for x. So that's going to be x equals y squared. So this graph right here is x equals y squared. So when I see x equals y squared, that gives me the distance. So this equation, y squared, gives me the distance from the equation to the y-axis. Okay? But the inside radius that I need is this part right here. It's not going to go all the way through. It will be flat on this end because it actually touches right here at this end. Because we're taking this and we're rotating it around. It's not going to go all the way through, but there's going to be like a bowl sort of shape out of it in the middle. So we're talking horizontally here. The distance from the line we're rotating around, this vertical line right here, to the outside of the figure, that is always a distance of 1 for this problem, right? Because we've got that furthest away line is going to be, that's always a distance of 1. So for the inside, this piece I've got right here in green, that's our y squared. But the purple is what we actually want. The purple is our little r of y. Okay, so what, well, little r of y is what I want. How do I get that?
You just do 1 times Get the square. Get the square.
1 minus the y squared. So 1 is that blue line that I have there, right? That has a length of 1. If I subtract this y squared, it'll give me the purple that's left over. Okay, so the picture's really important for getting that set up correctly. Whenever we do this problem, we have to have the outside and the inside for this one. So we are integrating from 0 to 1. It really doesn't matter whether you look at the x or y on this one, you'll still get it right, but we're looking at the y, right? The y is what we're supposed to look at. And we'll have pi times 1 squared minus pi times 1 minus y squared. So if you want to pull the pi out front, you could there. I probably would for typing it in. If you can split them if you want. Yeah, if you would rather do them as separate ones. Yeah, so if you want to write it like this, that's also fine. Yeah. So it's really just going to be like 1 minus y squared. Because 1 squared will just give us 1 there. So you can if you want, yeah. Yeah, if you wanted to, you could go ahead and square it and put that together because those 1s will go away if you do that. All right, 7 pi over 15. No, because when you square that, it's got to be 1 minus 2y squared plus y to the 4th. So you would have it like this. So you'd get negative. You'd have negative 2y squared plus y to the 4th if you simplified that. And if you had to do it by hand, you would want to you would need to do that before you actually integrated there. Okay? All right, questions? All right. All right, we got y equals x, y equals 3, x equals 0. We got to rotate around the line y equals 4. So y equals x is just this line right here. X equals 0 is our y-axis. And then y equals 3 is right here. And we are rotating around y equals 4. Okay, so this is going to be kind of cone-like, but with a hole through the middle. When we rotate this around this line here. So our outside radius here is going to be from this line right here down to the blue line. That's from our line we're rotating around to the blue line. So we need to think about how to write that.
Looks to me like
Is it constants, first of all? Is it going to be the same right here as it is over here? No. So that's not, our outside radius is not going to be constant. It's going to have the x in it. So when I have y equals x right here, y equals x, that gives me the distance from the x-axis to the graph. So that would, this little piece right here is x. So how do I find what I'm going to call that blue line right there?
4 minus x.
It's 4 minus x. Because we know this distance right here is 4. Right? So 4 minus the green line right here, x, will give us the blue line. You'll find that you're pretty much always either going to be taking the number you're rotating around and adding it to your graph or subtracting it from your graph. And pretty much all of the cases, you just kind of have to picture which one it is. And then for our inside radius, is just this piece right here. Is it constant?
Yeah.
Yes, because it's the same here and here and here and everywhere. And its length is just 1. So, if we set this up, what should our limits of integration be?
0 to 3.
0 to 3. And that is from our x-axis, not our y, although if you did it incorrectly, it would still be 0 to 3, because they're the same there. So we would have pi times 4 minus x squared minus our integral from 0 to 3 of pi times 1 squared dx. And so if we want to simplify that a little bit before we type it into the calculator, we could pull the pi out front. We would have 4 minus x squared minus 1 dx. And we would evaluate that. Because I want to set up the last one, I'm not going to type that into the calculator right now, but you could get the idea. There. All right. All right, last one. All right, so we've got y equals 2 minus x. So that's going to have a y-intercept at 2, a slope of negative 1. So that will be the blue line that I have graphed here. Then we have 2 minus 2x. So same y-intercept, but a slope of negative 2 over 1. So I have this red line here. And it's the area in the first quadrant. So it doesn't say that the x-axis is involved, but the first quadrant means that we're going to stop right here in this little area right here is what we're going to be rotating. Around the line x equals 3. Is that vertical or horizontal? Vertical, x equals 3 right here. Now, are either one of them constant this time? No. So, outside radius. That is this distance. Use red. This distance from the line to the red graph. What is that going to be?
3 minus x.
It's going to be 3 minus that graph for the red, which I need to solve for y. So that would be y, or solve for x. Y minus 2 equals negative 2x. So it's negative 1/2 y plus 1. So 3 minus negative 1/2 y plus 1 is our outside radius, which, yes.
Why would it be 2 minus 2? Why would it be the red?
So that red line gives you the distance here. So you have to do 3 minus that to get that red line. And then for the blue line, I'll just rain. We need this here. For our lowercase r of y, we would have 3 minus this one if we solve it for y. It's just, solve for x is going to be y minus 2 equals negative x. So 2 minus y equals x. So 2 minus y. And it's time to go. But I think that's the hardest part, is getting that capital R and the lowercase r. So the assignment for tonight is on Canvas. I am going to make it due on Monday because you do have test corrections and FRQs that are due tomorrow. You have a quiz on the FRQs, yes.
No, I mean,
The homework, no, sorry, I'm on the wrong thing. The homework is from the textbook. It is 225 again. 425, I mean.
Okay, I've set like 8
All right,
pictures.
so I'm going to change the date for that to be Monday, so that you can do that over the weekend instead. Do I need to?
I have one.
There's some white ones. There's some white ones. You can use those white ones, yes. Here you go.
Rainbow test correct.
What have you got third period, Logan? If you want to come, if you get stuck on anything, we'll look at it. I'll be here tomorrow, so come by. Cause were you one of them that do not know how to solve a differential equation? That left those parts blank? Okay, good.
I figured it out on the last question. Actually, surprised me.
Yeah.
Either that or I did it right on the FRQ.
Okay.
quiz thing.
Yeah, cause I was thinking you were one that left a lot of that part
Yeah,
blank.
I left a lot of it blank, but then somehow I got one right at some point.
Okay, so you kind of know what you. But if you need any help, I'll be here.
I like how the feeling of college when there's no bells.
Mm-hmm.
Because just everyone's standing here and still working after the bell. Because in college it isn't really like, a lot of times it's just about.
Mm-hmm.
It's not like exactly like.
Yeah.
in high school.
Yeah.
Exactly.
Yeah.
So I don't really like that aspect of college.
Yeah. You got a little longer between classes, so you don't have to be quite on such a schedule.
There's no like bell. Yeah. There's no bell.
Yeah.
So you get to be on schedule, and it isn't within a 4 block thing necessarily. It's so great. I can't wait.
Still recording.